YouTube. This is part 9 of how to build a Raytracer from scratch in C++. And in this video I want to add a class to render triangles. But sort of starting where I left off in the last video, you might have noticed that shadows are only showing up underneath the first object in our scene and not any of the other objects. And that's because I made a mistake. What's supposed to happen is we trace a ray from the camera through a pixel on our image plane into the scene. We found a primary intersection, and then we went from that primary intersection to the light source. If we encountered any secondary intersections, we wanted to loop through those secondary intersections and determined if an object in that secondary intersections vector created a shadow. But what's happening right now is it's breaking after the first object in the secondary intersections vector and not checking to see if any of the other objects in the scene create a shadow as well. So we can fix this by going into the getColorAt function and scroll down till you find the for loop that loops through our secondary intersections array, and this break statement is exiting the for loop once this shadowed value becomes true, but it's doing that after the first object in the scene and not checking the rest of the objects. So we can move this break statement up one line into the if statement above it, and now it will loop through all the objects in our scene to check for shadows. And there's the shadow now created by the maroon object. And you can also see the shadow in the reflection if you look closely. So now we're ready to start dealing with triangles. We're going to create a new class, the triangle class, and we'll give it 3 coordinates for the points A, B, and C, the corners of the triangle. And then to render triangles, we'll need to find the plane that those 3 points lie in, and then we'll find the distance from that plane to the origin, and then we'll find whether or not the intersection between the ray from the camera and the plane that those 3 points lie in is inside of the triangle or outside of the triangle. So first, to find the plane, we'll take the cross product between 2 of the legs of the triangle. So if we have the cross product between points B and A, the vector between B and A, cross product with the vector between points C and A, we'll get a vector which is perpendicular to those 2 legs of the triangle, which will also be perpendicular to the plane that the triangle lies in. But the order matters, because if you take the cross product of the vector BA with the vector CA, the normal vector will be pointing away from us, but if you take the cross product of the vector CA with the vector BA, you'll end up with a vector which is the normal of the plane that the triangle lies in, and it'll be pointed in the direction of the camera. So that just has to be kept in mind when you define your triangles. The order of the points in the triangle has to create a normal which is in the proper direction, or otherwise it won't render properly. So I'll create a new class, create a new file, save it as triangle.h. We're going to take our plane class, copy, and paste that, and then replace plane with triangle. But instead of supplying the normal to the triangle class, we're going to supply it with 3 vectors for the points A, B, and C. We'll use those to compute the normal. And the way we compute the normal is by taking the cross product between vectors CA and vector BA and then normalizing it. So we'll say CA that's the x-coordinate of the vector CA. Now we need the y-coordinate and the z-coordinate. And now we need to define another vector, which is between the points B and A. And now the normal vector is CA cross product BA normalized. The distance that plane is from the origin can be found by taking the dot product of the normal with one of the points in that plane. And we use A. The normal at any point of intersection will be the normal of the plane. We'll go ahead and move down here, change these. So now, all we have to do, this piece of code returns the distance to the plane that the triangle lies in. Now all we have to do is determine whether or not that intersection point is inside of the plane or outside of the plane. So we'll add a few more things here. And now this value, that's the distance from our camera to the point of intersection on that plane. So we'll say and we want to return this value if we're inside of the triangle. But if we're outside of the triangle, we want to return -1 and it will know that we missed the triangle. So how we check to see if it's inside the triangle or not. It's easier to just show you the conditions than to try and describe it. We'll have 3 conditions, and if these 3 conditions are true, we're inside the triangle. And those are, if we take the vector CA and cross it with the vector QA, which is the point of intersection. Q is the point of intersection. If that dot product with the normal is greater than or equal to 0, and 2 other conditions are met, then we're inside the triangle, otherwise we're outside the triangle. These are BC and QC, and these are AB and QB, where Q is the point of intersection. And the point of intersection is this distance along the ray direction added to the origin of the ray. So we'll find the x, y, and z coordinates of the point Q, ray direction multiplied with this distance and then we add the x-coordinate of the ray origin. That's the x-coordinate of our point Q, the y-coordinate, and we need the z-coordinate. And now our point Q can be defined as QX, Y, QZ. And now we need to test for these 3 conditions. So we've already defined the vector Q, CA up here. So we'll copy these. And the second vector is the vector between points Q and A. And now we need to create a condition which is CA cross product QA, and that whole expression needs to be dot product with the normal. And now we copy these and we make a similar expression here, but this is BC QC test 2 is BC cross product with QC dot product with the normal. And then our third condition AB, and the second vector is QB, and test 3 is AB crossed with QB, dot product with the normal. And now if test 1 is greater than or equal to 0 and test 2 is greater than or equal to 0 and test 3 is greater than or equal to 0, if those are true, then our point Q is inside of the triangle and we return the distance to that intersection point. Let's compile, see if we have any errors. Compiled good. And now we can create triangles in our main class by creating new instances of the triangle class. So I'll create a new instance of the triangle class. We need 3 points. I'll make it, so that's our point A. That's point B, and this is point C. And we'll make it a new color, call it orange. Now we need to place that triangle in our scene objects. And now we should be able to render that triangle. And there you see is the triangle we rendered. This point to the far right here is our x coordinate. So that's A. And then this corner over here in the far direction, that is the z coordinate, so that is C. So this is A, this is B, and that's C. And you can use these triangles to create other shapes. For cubes, what I did was I created a function which took in 2 corners of a triangle, 2 corners of the cube, and computed the other 6 coordinates of the cube. So here's sort of a diagram of what I'm talking about. I made a function that took in corners 1 and corners 2, and then it computed the other 6 coordinates of our cube, and then created 12 triangles along with 2 triangles along each face of the cube. So we'll say the x, y, and z coordinates of corner 1 are and we'll need its y and z coordinates. And then we also need the same thing for corner 2. And now we can compute the coordinates A, B, and C, and D, E, and F from those coordinates of corner 1 and corner 2, like this. A is C2x, C1y, C1z. And now we can create triangles on the faces that lie between these coordinates. I'll say left side this next corner is 1, E, D, our side, D, 2, side, E, 2, F, side, E, D, and this is F, E, top, G, E, F, F, 2, D, And now we should be able to make a cube. Oh, one thing I forgot. In order to access our scene objects from our make cube function, this needs to be outside of our main function. And now we can define a cube. So I'll hide our triangle, and I'll hide our first sphere, and create a cube. Now the order of these vertices I've chosen in order to render it properly, because this won't render just any coordinates. The coordinates will have to be in a certain order, or else the shadows on the cube won't render properly. And now you see it's rendered a cube. So I hope this has been a good tutorial for you guys. And if I get it to render cylinders and cones, I'll add that class as well. Thanks for watching.